but that is very wrong.
Okay.
So that was the goal of answering that question, this project. So first you have to find
So the question was, what are the different colors in a leaf? Is that the question?
how to find
Ah,
colors in the leaf.
what are the different colors?
So first you should find different leaves of different colors as shown. Then you then you should mash them up into bits and put them into separate test tubes.
Did you just mash it with pound? Like you pounded it?
Like this.
Yeah.
And then you should put rubbing alcohol into each of the test tubes.
Okay.
So and after that we should let it be like that for one full day. So then in the morning you should put filter paper strips into each of the test tubes and let it be like that for 5 hours or so.
Okay.
So after 5 hours, when you remove the filter paper strips from the test tubes, you will see these colors. It was darker before, but because rubbing alcohol just evaporates into the air, we couldn't help it.
Okay. And so, what are the different colors you found?
Different colors like red, brown, yellow.
Mature green. Okay.
Yellow, green, yellow, brown, new green.
So from red to green and yellow and brown. Okay.
So this is a very fun experiment because you get to find different colors in a leaf.
Okay.
So you see mostly these different colors of leaves in the winter. Because in the winter, the plants and the trees they call all the chlorophyll from the leaves and store them in their storage cells. Since there is no sun, since there is no chlorophyll, the other colors take the spotlight and shine through.
I see. So these the colors that you showed, like brown. Can you open that page for me? The brown leaf was like in the winter. Was a winter leaf.
Yes.
Or this yellowing one.
Yes.
Okay. Okay. Thank you. Hi.
Good morning.
What's your
My name is Nilesh. So my experiment,
Nilesh, where are you from?
Kerala. So my experiment is the fastest way to drain water. So this is the normal way. We just tip the water bottle down, let gravity do its thing.
Yeah.
So what happens here is a lump of water falls down, and so it creates a vacuum. So the air has to get in. So the water speeds up and slows down because of air. The next way is to create a vortex by swirling the bottle.
Oh,
What
it's
happens here is the air gets into the center and pushes the water down from the sides.
so that was the faster one.
The fastest one is to use a straw and blow through it.
Nice.
Here, there's an extra passage through which the air can get in and push the water down from the bottle. There will be no disruption between the flow of air and flow of water.
Very cool. Thank you.
Welcome.
I'm Nikisha and today I'm going to explain density and buoyancy with the help of the summary.
Nikisha, where are you from?
I'm from here.
Here, Bangalore?
So as we know, the leaves float and the stone sinks. This is because the force applied by the object acts downwards and the buoyant force from the water acts upwards. So if the buoyant force is more than the force applied by the object floats like this leaf. Submarine has a compartment which first is filled with air, so it can float. Later on,
Okay.
what makes it to come faster, I'll just see the water back. Take it out like that to it, making it less dense. It can float again. This is how the submarine.
I see. Now, can you? Thank you.
Water, it experiences an upward force which is equivalent to the water displaced by it. Now I am going to tell it to you by various methods. When we put this can into the water, it's more weight, and this can has less weight. So it is more. So
it sinks and it floats. When I put this can into the water, it floats because of the upward force formed by the water is more than the weight of the because
Yeah.
because the weight has increased of the bowl. Now when I put some more water in it, it still floats but it has gone down because the weight has increased more. Now when I fill it 3/4, it still floats but it is floating at the edges. So it's not sank completely but it's almost
A
sank.
little bit.
When I fill it to the fullest, it sinks because now the upward force can't handle the weight of the bowl and the extra
Right.
water in it. Thank you.
Thank you.
Good morning, sir. Good morning, ma'am. My name is Palashi Satish Kumar. I'm from grade 4, Residential School, Bangalore South. I'm trying to explain the principles of science through this roller coaster model.
Sorry, the principles of
Science.
science. Okay.
I have made it using paper straws and not sit here. Transforms into kinetic energy and then rotation energy. This can also transforms into kinetic energy and then rotation energy. This can also sometimes be used to generate electricity. Thank you.
Thank you. That was real. How long did it take to make the whole thing? 1 week. Nice.
In the last 20 years, more than 684,000 farmers
Hi.
have committed.
What's your name?
My name is Raka.
Ritvik, where are you from, Ritvik?
I am from Millennium World School in grade 3.
In Bangalore?
Yes.
Okay.
So today I'm going to be performing to you a water pump science experiment.
Mine is a clean
Okay.
For this experiment, we've been using a bottle, liquid water, a coconut of water, and inserted a straw.
1 second. We'll just wait for him to finish because I can't hear you.
irrigation, sprinklers, etc. Right? But they all consist some fossil
And you need a big bowl and a bulb.
Yes.
Let's start by filling the
two
bulb.
major setbacks for the farmer. Because first of all, the farmer's profit margin will decrease drastically because they have to basically spend on the electricity because the fossil fuel prices are now skyrocketing. And secondly, fossil fuel creates greenhouse gas emissions and that leads to climate change. And that
Now let's see what happens.
and
3, 2,
climate change makes rainfall at the wrong time.
you see the water coming out.
Yeah.
At the
So let me tell you the science behind this experiment. Basically, the air inside the balloon is at a very high pressure. And the air always tries to achieve equilibrium as we all believe. So the air is pushing the air inside the water. It is pushing the water out as well as like a water pump. This process continues until equilibrium and air pressure is fully achieved.
Okay.
Now let me tell you some day-to-day examples of how equilibrium of air pressure is achieved. So, one is when you open a soda can. Two is when you deflate a balloon.
So when you open a soda cap, the sound that it makes,
Yeah,
is
the
that
sound that it makes is the hydrogen trying to
come out?
escape, which causes the equilibrium to be achieved.
And what is equilibrium?
Equilibrium is the air pressure to be synchronized.
Okay. Like all equal all over?
Yeah, equal all over.
Nice.
put crops in.
So yeah,
Thank you. That was really nice.
thank you,
It was a very simple and elegant explanation of it.
thank you.
Hi. Can I start? Hi. What's your name?
My name is Rudram Sanjeev from class 3, Sri Sri Shankar Vidya Mandir, Mumbai.
Okay.
So, imagine a reservoir of water directly on top of kinetic and rotational energy and makes the turbine move, which in turn makes the wheels of the car move and eventually the entire car move. And do you know that this invention can be used to save farmers' lives?
Really? How?
In the last 20 years, more than 684,000 farmers have committed suicide just because of lack of irrigation. And irrigation is the backbone of agriculture. So, whenever we think of irrigation, we always think that drip irrigation, what sprinklers, etc. But they always have some use of fossil fuels, and that's two major setbacks for farmers because first of all, fossil fuels lead to more greenhouse gas emissions, and then and makes climate change even worse. And climate change is solely responsible for rain happening in the wrong time and not happening at the correct time. So, for some ad, so and secondly, we can all we their profit margin decreases drastically because fossil fuel prices are increasing, skyrocketing in the market. So mine is a clean, green, and a renewable source of energy. Water.
Okay.
So whenever you think of water cars, you always think of the electrolysis of water, that's turning it into two hydrogen and one oxygen atom, and then combining them together to form energy. But like the Toyota Mirai, but mine is actually a water car because it works on water. And for some add-ons, you can also add natural fertilizers like nitrate into the water, so that it also waters as well as fertilizes the crops as well. So
Can I ask you a question? So this vehicle is you're imagining is going to be on the field watering plants.
yes.
Okay.
So when I grow up, I'll try to make a better model of this. When my motor skills improve, I'll use industrial grade materials, and I'll make it bigger. And I even put a valve. I even may put a valve here to like control it, and also and I'll make a larger version of it so that it will be more efficient, and I'll sell this on the market to farmers, and this can actually touch farmers' lives. Can't it touch farmers' lives? Can't it save farmers?
Definitely will have an impact. Does this move?
Yes.
Oh, okay. Does it, have you tried it or is it just a model?
I can work. First I have to close this and then I'll take the water.
Do you need me to help you in some way?
I'll pour some water here, and when I leave it, this will actually work.
It rotates.
But while traveling, it actually kind of broke.
Yeah, but we get an idea of how. So we saw the wheels spinning a bit. Nice. Thank you. I'll continue.
How the structure of the rocket supports rocket launch.
But first, can you tell me your name and where you've come
My
from?
name is Raj.
Where are you from? Bangalore?
No.
Where are you from? Chennai. Okay.
The body of rocket should be in cylinder shape. The body of rocket should be in cylinder shape.
Cylinder. Okay.
The concept help rocket to moving forward. I have attached a magnet in this half cut. The circular shape head is not closed because the drag force pushes the rocket back.
Okay. What is drag force that you mentioned?
So this magnet
It's the air coming from this
is
side?
attached to this steel handle, and now it is spinning. These are things. It helps the rocket to move up. Balance rocket weight. Spinning top is spinning because of the gravitational satellites top loaded. Balance rocket weight. I use vinegar and baking soda to launch my rocket. It forms carbon dioxide and goes up. Thrust tax. Newton third law means every action has an equal and opposite reaction. In real rocket launch, they use fuel and engines. Thank you.
When you mentioned Newton's third law, no? In your experiment when you used carbon dioxide, how did it work? Do you know? What is the opposite reaction? Do you where it pushed down? Yes. Thank you.
So this is my magnetic spinning top. So I have attached a magnet in this plastic half cut ball, and I have sticked a colorful paper disc, and now this magnet is easily attached to this steel hanger. So now it is spinning,
Oh,
and it is this magnetic spinning top is spinning because of the gravitational force and the curved face of the ball.
what's your name?
Sanvi.
Sanvi. Nice. Thank you. Hi.
My name is Satvik from class 3A. I'm studying in KVIS. Today we are going to talk about thermal energy. The objective is that to demonstrate the concept of the thermal energy and heat transfer.
Heat transfer.
For the first experiment, we will talk about air medium. So when we keep the water inside the hot water, the balloon will start to expand. And then when we keep in the cold water, the balloon will start to deflate. This is because when we keep the water inside the hot water, there's a heat transfer between the hot water and the air inside the bottle. And when we keep inside the cold water, there's a heat transfer between the air inside the bottle and cold water. Next, you're going to be using this thermometer. When we keep it in the cold water, the thermometer will be starting to rise. This will take some time to rise. And when we keep in the cold water, the thermometer will start to the water level inside the straw will start to go down.
So can you explain how the thermometer works? I didn't realize this was a thermometer.
Yeah. See, when we see in the water, we need to keep colored water and then cap. Inside there will be a hole in middle of the cap. And there will be a straw passing through the hole of the cap. And then covering it with hata so that the heat does not.
So the level of water in this straw, the blue liquid, that's telling me the temperature, is it?
Yeah, no, the black liquid.
The black liquid?
Yeah.
So if I move it here, that level of liquid will change?
Yeah, it will change.
Oh yeah, it comes down.
Yes, it changes. This is because when we keep in the thermometer inside the hot water, there's a heat transfer between the hot water and the liquid inside the bottle. And when we keep in the cold water, there's a heat transfer between the liquid inside the bottle and cold water. And then next we are going to make some ice cream. For this, we are going in the small Ziploc bag. We are going to be keeping milk maid syrup and fresh cream. And in the big Ziploc bag, we need to keep some ice cubes and rock salt. The ice cubes are being and then keep the small Ziploc bag inside the big Ziploc bag. And then shake well for 5 to 10 minutes. After shaking well, we can remove the Ziploc bag and then
It's solidified, no?
yeah, ice cream is this is because there's a heat transfer between the salt, between the ice cream and the ice cubes.
Okay, thank you. This way? We're going too slow? Okay. Then I'll, don't ask so many. No questions. Okay. Okay. Keep it shorter then. So they don't have to show it.
They don't have to explain it.
Okay.
What is the concept? How this model?
Hi. What's your name?
My name is Arish.
Okay. What have you made?
I made a harmonica model.
I won't be able to see the whole thing, but could you tell me what your harmonica model was trying to show us in science? Like what is the scientific
Then
concept?
when there is more more space, there is more air to vibrate. And it also shows that things vibrate and create sound.
Okay. All right. Thank you.
I have another magnet.
Do you want to know their experience also? Their experience also? We just keep this way. You want to know their experience?
At least front.
What's their name? Where are they from? What's their model code?
That's all, no? We don't have to ask how are they feeling about it.
Yeah, we can ask. How excited are they?
The two points is hydrophobic. I have spread.
I think. Are you doing something? Hi. What's your name?
My name is Arav Dhanrajka. So
I won't be able to see the whole thing, but where have you come from?
I've come from Pune.
From Pune? Okay. And what is the concept that you are demonstrating?
So this is the straw oboe, and I am telling about low pressure and high pressure.
And how to create sound?
Yes.
Is it already made? Do you want to show us the sound it makes?
Yes. So when we blow through it, it creates sound. That is because of the air coming out of our mouth. So it pushes the air inside it outside. So now there is a low pressure formed inside the straw. So now the atmospheric pressure around it tries to get in it. So it pushes the straw from all sides, closing the reed. So as we're still blowing, we force to open this reed again. So
That makes the noise.
yes,
So
so
that
this creates vibration, and vibration produces sound.
Sound. Thank you. Hi.
Show a demonstration of magnets.
But before that, can you tell us your name?
My name is Ayansh Kumar and I study in National Public School, Vaidhi, and in grade 3. I'm going to show the demonstration of magnet. I have placed this dark magnet here and I'm using this wire to push it, and I'm going to see where it attracts.
Okay.
It's on 4 centimeter north.
Oh, so this essentially you're trying to show us how strong your magnet is? Okay. So are you tested it on different kinds of magnets?
Yes.
All right.
On 2 centimeter, it is attractive.
I won't be able to see all of them. Can you show us just the strongest magnet you have? The one that is the least or that can be attracted from the greatest distance?
I'll try to. Okay, so this is a dark magnet. I'm going to push it. So from 3 centimeters, it
can-
is attracted, and it is the strongest magnet I have.
That you have.
On the second experiment, I have a car, and on top of it, I have placed a magnet. I have a magnet over here now, and I've written B for back and F for front. If I place F over here,
Oh, it
it
moves
goes
the.
front, and if I place back, it goes back.
Nice.
And now I have a skateboard, and I have placed a big round magnet, which is the strongest magnet I have, on top of it.
Nice.
So it is coming towards the dart magnet. It is attracting. If I turn the face around,
It moves it away.
it's repelling. So that is the demonstration of magnets. Thank you.
Thank you.
We can start by, for example,
Hi. What's your name? Where have you come from?
I have been come from Ludhiana.
Wow, that's far away. You have a lot of things here. Can you tell me what your
Ma'am, my project is hydrophobic and hydrophilic materials.
what is hydrophobic? Means
Hydrophobic material means materials which repel the water.
Oh,
And
so they don't like.
hydrophilic materials means materials which are attracted by water.
So I won't be able to see everything. Which was the one that you were most surprised by? That this is hydrophobic, or this is. Which one did you find when you were doing your experiment? Which is the most interesting one? Did you find?
Ma'am, silicon ash.
Can you show me?
this only.
Is that going to be like liking water or not liking water? Like hydrophobic or hydrophilic?
Ma'am, it is hydrophobic. Carbon
Okay.
dioxide underground and turns it into.
Oh, it makes little like balls. Oh, that's very
However, hydrogen can also be produced
interesting.
by water. After all,
Thank
water
you.
is just made up of
That is interesting.
hydrogen and oxygen. So,
Shall we move?
hydrogen, so, and is electricity and then
Sometimes you can just show this itself, right? Can't hear.
I
Huh?
think we should finish it fast.
Then we'll just skip some. I can't see. We'll go there. Yeah. Hi, what's your name?
My name is Shamyata, studying in 3rd standard Excel Public School, Mysore.
My, 1 second, Shamita. What? Before you continue, could you just give us a brief explanation because we might not be able to see the whole thing. You'll just tell us in short.
So for this, our body has a built-in cooler. Sweat is produced when we are sweat is produced when we are hot. But its purpose is to cool our body.
Correct.
So for this, we need a hair dryer to chocolate covered candies, cup, and scissors. So we are going to use. So for this experiment, not harmful.
Is this like supposed to be? There's chocolate in this, and you're testing to see how fast it'll melt.
Yeah, so the thing is here, I'll like wrap one half, I'll wrap it around one chocolate and I'll wet another half and wrap it around another. If I hair dry it for 5 minutes, this will melt and this will not.
And so this is like sweat on our skin. That's how you've connected the two. Then
So
you
what?
started by saying something about sweat, no?
But if this water, the chocolate did not melt because the water evaporated.
Okay.
And
So
this,
protect.
the chocolate melted because this.
There's no water.
Yeah.
Got it. Thank you.
also ask parents.
Yeah, do you see that?
The carbon dioxide cannot escape.
Where can
Now,
ask?
we are going to cover these two candles.
We'll go there directly. Hi.
Hello ma'am, I'm Vijay from Shinikadan Parsala Vengumbakam. Here I made my own popsicle.
Oh, it's a catapult.
Yeah.
Can you show us just two, just from here? From this.
I'm gonna load this in the basket. I pull down stick, potential energy, resting energy store. This stick,
Oh.
potential energy is converted to kinetic energy and movement energy.
I
And
see.
gravity eventually pulls back to ground. So popsicle catapult works.
That's
You
how.
may ask a question: what is potential energy, kinetic energy? Potential energy that is in rest and that has its own position, its own energy is called potential energy. Example of potential energy is I'm changing the position and the height is and the energy is also increasing. So example of potential energy. Example for kinetic energy is I'm pushing this catapult and it has motion. That is called kinetic energy. Thank you.
Thank you. Did you come on your own?
No, my parents.
Then?
This is a plastic rubber and this is the glass rubber. Think it this way. Glass rubber have heat in water because
Are you a parent? Can we ask you a question? Is this where your child is?
Kid has gone for seeing other
That's okay. You can.
We just wanted to know what your experience. You're from Bangalore?
No, I'm from Mumbai.
Oh, so your son or daughter?
My son is there. He's experimenting total equilibrium. So his concept is
Okay, that is yeah.
that. So if you want to balance the pencil vertically, it is hardly
It's not able to
impossible
do
for
that,
him.
yeah.
So what he has put, so how the gravity will work. So
We
anything
can,
to balance, the gravity has to work.
but actually, I was interested in your experience because I will,
Yeah, okay. So the experience for this
for
or
your personal experience from, I suppose at home watching your son go through this and coming here.
yeah. So the experience was very inspirational from my side because at our age, what we were doing is the small experiments, small playing at our home, and we were not having that much what you say exposure to all this. So when I see the kid is also experiencing and doing this all activity, but due to this platform, so he got an opportunity to display here. So it gives a motivation to every
Right.
child, not even my child, but all the kids who are there finalists. I think they have the enthusiasm. I can see their